Now, this part of the shaft design, we are looking into some work examples. Okay, some work examples, and then in this slide here, you have two examples. Now, example 1, let me read it out, okay? So, a line shaft rotating at 200 RPM is to transmit 20 kilowatt. The shaft may be assumed to be made of mild steel with an allowable shear stress of 42 megapascal. Now determine or find the torque transmitted. And part B, based on the strength relationship, find the diameter of the shaft that is required to transmit the given power and speed. So the power given is the given power is 20 kilowatt here, and the speed is 200 revolutions per minute. So based on the strength relationship, we have to find or determine the diameter of the shaft. Now in this case, we neglect the bending moment. So now this is a shaft, an example of a solid shaft. Now based on strength relationship, we have the equation of T over J equals to the shear stress tau over R. So where T is the torque and J is the polar moment of inertia, tau is the shear stress and R is the radius. So what they have given us the allowable shear stress, or you may consider this as the maximum shear stress of 42 megapascal. So and the radius here, okay, so this is the one that you have to find, and based on the polar moment of inertia, which you have pi d4 over 32, then you will be able to find out the diameter of the shaft. So about the torque here, so based on the power and the speed, we will be able to determine or find the torque that is being transmitted by using the formula given here, which is 2 pi times n, which is the speed of the shaft in revolutions per minute, divided by 60, that is to convert per minute here to per seconds, so that you can get the watts later on. So and then the torque should be in Newton meter. So now what we need to do is to find out the torque with the given power, that is 20 kilowatt, that is 20 times 10 to the power of 3 watts, 2 pi n, where the n is 200 revolutions per minute. So you have this, and then you have torque is equal to 60 multiplied by the power, that is 20 times 10 to the power of 3, divided by 2 pi over speed of 200 revolutions per minute. So you got a torque of 954.9 Newton meter. So then after that, after part A, then we go for part B. So based on the diameter of the shaft, because it is required to find, we are required to find the diameter of the shaft. So first thing is the polar moment of inertia of a solid shaft. So for a solid shaft, we have pi d4 divided by 32. So if we were to substitute this J, which is equal to pi d4 over 32 into this equation, and the radius, which is diameter over 2, so it comes to this equation here. Manipulating this, 32 with 2, you have 16. D to the power of 4 with the D here, so you have D cubed, and tau max. So diameter, so you can find out the diameter as 50 millimeter. That's the first example. So now we go to the second example. Again, let me read it out. Okay, let me read out the questions first. A solid shaft is transmitting 1 megawatt, so 10 to the power of 6, and a speed of 240 RPM. Determine A, the mean torque and the maximum torque that can be transmitted. If the maximum torque transmitted exceeds the mean torque by 20%. Part B, the diameter of the shaft. Take the maximum allowable shear stress as So this is the maximum tau, okay, the maximum shear stress of 60 times 10 to the power of 6. So first thing is to find out the mean torque. So usually when we refer to the power formula, the power which is equal to 2 pi n over 60, in the question, if let's say the question asks us to find maximum torque, that means the given torque should be a mean torque, or the torque that we found from this formula usually is referring to the T average or the T mean. So the T mean is 60 times P over 2 pi n, where P is the power, 1 megawatt, that means this is 1 times 10 to the power of 6 here. 2 pi multiplied by the n, which is the 240 rpm. So you got a torque T mean 39.79 Newton meter. Then in the question in part A, they have stated that the maximum torque is to exceed the mean torque by 20%. So here, maximum torque transmitted exceeds the mean torque by 20%. So you have T max is equal to 1.2 times T mean. So you have this. So you can find out the T max of 47.7 Newton meter. So then after that, again, polar moment of inertia. Okay, for solid shaft, pi d4 over 32. It's the same thing, repeat again. So this time, you have a torque T max of 47.7 and a tau max of 60 times 10 to the power of 6 Pascal. Now, the difference between this example and the previous example is, now in this example, they have include the T mean. Okay, so that's all for this section. You have 2 examples here. So the rest of the examples will be on the later slides again. So if you have any questions, please put your comments on the comment section on my YouTube channel of my podcast. Thank you very much. Bye bye.